Okay, here is a video on graphing radical functions and then using algebra to check that your graph is what you expect it would be. Okay, so let's just say we have two equations, and our equations are f of x is equal to the square root of x plus 1, and we have g of x is equal to x. Let's first of all graph both of those in the same Cartesian plane here. So this is the square root of x function that's been shifted to the left by 1. So the normal square root of function has 0, 0, 1, 1, and then it's got 4, 2, and then it's got 9, 3, but it looks like this. Now this, because of that plus 1, has been shifted to the left. So what this is going to look like is going to look like this. 0, 0, or negative 1, 0, 0, 1, and then we're going to have 3, 2. Now just test these points and see if they work. For example, if I plug a 3 into this equation, then I end up with a square root of 3 plus 1. So the square root of 3 plus 1 is 4. That's going to be 2, and so I end up with a 2. So I put a 3 into the equation, and I got a 2 out of the equation. So I have the point 3, 2. So you can check each of those points. I suggest you do. Try, for example, plugging in a 0 into the equation, and you should get a 1 out of it. Plug a negative 1 in, you should get a 0 out of it. So we have this equation. We're going to graph it like that. And now we have another equation called just x, so y equals x. So for this one, let's switch colors. We have the point 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, and we have all of these points. And the question is, where do these things cross? And it looks like on my graph we have a decimal answer. Let me just check and see if I did this wrong. Square root of x plus 1. Okay, yeah, and it looks like on this one, probably not on the test, but the way I drew it, it looks like we have kind of a weird solution. So let me just go down here. This looks like, I'm just gonna say like 1.5-ish. And so for this one, you would say the solution, or the intersection point, is x equals 1.5-ish. Now 1.5-ish is not a very satisfying answer, so let's go now and solve this algebraically. So solving this algebraically, we're going to set this guy square root of x plus 1 equal to x. And we're going to square both sides. And when we square both sides, we end up with x plus 1 equals x squared. And now we're going to have to subtract x from both sides, subtract 1. And we end up with 0 is equal to x squared minus x minus 1. And we try to factor that. Unfortunately, this thing won't factor, and so you'd have to use the quadratic formula, and the quadratic formula would give you 1.5-ish. So this turns out to not have been a great question on my end, because you can't really see a great intersection point from the graph, and it's also a fair amount of work to get there from the quadratic formula. You won't have to do the quadratic formula on the test. So this turns out to not have been a great question. So let's keep on going and do the next one. Okay, so for this one, we've got f of x is equal to the square root x plus 2. And we've got g of x is equal to 2 square root x minus 2. Now these are both transformations of the square root function. And the square root function again goes through 0, 0, 1, 1, 4, 2, 9, 3. It looks like this. Now this function right here has been shifted to the left. Let's get a different color for this guy. That guy has been shifted to the left by 2. So it looks like this. That guy has been shifted over by 2. That's been shifted over by 2. So it looks like this. Now this function right here, that's been shifted over to the right by 2. So you get that point, you end up getting that point, and you get that point. But it's also been amplified by a factor of 2. So that gets twice as big, and this one gets twice as big. So what it really looks like is this. And you can see these guys are on a collision course right around here. So it might be exactly 3. It might be a little bit more than 3. It's kind of hard to tell. But let's go ahead and solve this algebraically and find the solution. We're thinking the solution is 3-ish. All right, so let's do this over here on this side. We've got square root x plus 2 is equal to 2 square roots x minus 2. We're going to square both of those sides. Now, when we square the left-hand side, the squared and the square root symbol cancel each other out, leaving us x plus 2. And on the other side, it might be helpful to write this out the long way so we can really see what we're doing. Okay, when we write it out that way, we can see that our answer now is going to be x plus 2 equals this 2 and this 2 become a 4. And this square root of x minus 2 times the square root of x minus 2, well, that is just going to turn into x minus 2. All right, let's clean that up a little bit. That's going to give us x plus 2 equals 4x minus 8. And from here, let's subtract an x from both sides. And let's add an 8 at the same time. When we do that, we end up with 10 is equal to 3x. Dividing both sides by 3, we end up with 3.3333 is equal to x, which is exactly what we got graphing. Well, kind of exactly. We got 3-ish graphing, and we got 3.333 repeating when we did the algebra. Okay, I think the rest of this, you guys are good to go. If you got any questions, you can send me a message. Good luck, guys.